We will continue our discussion in Chapter 4, talking about scientific notation. A lot of you should be familiar with scientific notation if you have taken any science class. We like to use the scientific notation to express numbers that are really, really large or really, really small. It just makes our life easier. We replace the large or small numbers, so replace those zeros by using a power of 10. Here's the expression of a number in scientific notation. So here's my number followed by or multiplied by 10 raised to a certain power. In this scientific notation, my number has to be between 1 and 10. It cannot be smaller than 1, so it can't be 0.1, 0.9, 0.8, etc. And it can't be 10 exactly, because I can still move that decimal place by a power of 10. So it can be between 1 and 10. Larger than 1, but smaller than 10. So 1.5, 1.2, up to 9.9, 9.9999, etc., but it can't be 10. Now, n, the little n here, can be a positive or a negative number. Positive integer, so if it's a positive number, that expresses large numbers. If it is a negative number, then we are expressing small numbers in scientific notation. So here's an example. If I have 150, the decimal point is at the end here, at the end where the 0 is done, right? So to express this in scientific notation, remember that my number has to be between 1 and 10. 150 is much larger than 10. So how do I make it smaller? Well, I can move that decimal point to the left. So if I move it one time, now it's 15.0. It's still larger than 10. I need to move it one more time. So if I move it one more time, then it becomes 1.50. Here's the equivalent. So I moved that decimal point twice to the left, and I got a number that is between 1 and 10. I can stop. That's where I'm done. Now, because I moved it to the left, I will have a positive number. So this is 1.5 times 10 followed by how many times did I move that decimal place? Since I moved it twice, that I moved the decimal point twice, then that means that the power of my 10 is going to be 2 because I moved it to the left. If I moved it to the left, that means that I have a positive n for the power of 10. So 150 is equal to 1.5 times 10 times 10. 1.5 times 10 gives me 15. 15 times 10 gives me 150. So I have two 10s that I multiply 1.5 with. And therefore, if I combine those two, I will have 10 to the power of 2. We also say 10 to the 2, 10 to the second. So 1.5 times 10 to the second. Let's take a look at a number with a negative n. Let's take a look at 0.5. This number is less than 1, so it's not between 1 and 10, like I need it to be for scientific notation. Note that the decimal point is between the 0 and the 5. Well, if I move it to the left, then it becomes 0.05, so it's becoming even smaller. If I move it to the right, then it becomes 5. So that 5 then is the correct way to express it because it's between 1 and 5. The fact that I moved the decimal to the right is going to give me a negative n for the power of 10. And since I only moved it once, then my 10 is going to be raised to the power of minus 1. So it's going to be negative, but I only moved it once, so -1. If I moved it twice, it would be to the -2. If I move it 3 times, to the -3, etc., etc. So 0.5 can be expressed as 5 times 0.1, so 0.1, which is really 10 to the -1. So 5 times 10 to the -1, because I moved the decimal point once to the right, and if I move it to the right, I have a negative in front of my power of 10, and the 1 tells me how many times I've moved it. I moved it once, so 10 to the -1. Here is a sample problem. Write the following numbers in scientific notation. We have all large numbers. Note that large numbers will have positive powers of 10, so little n is going to be positive. And, however, since you're moving, obviously the decimal point is right at the end of these numbers, and you're moving to the left. As you're moving to the left, you will have a positive n for the power of 10. How many places you are moving it to the left is going to give you the actual n value. I will give you some time for you to try these problems. Okay, let's take a look at a very, very small number. The mass of water, a water molecule in kilograms is determined to be this number here. Now you can see why it's very easy for us to use, or important, if you will, to use the scientific notation, because if I am doing work with this number, I'd have to write all of these zeros every time I would write this number. So it's not very convenient. Now, this is a much, 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 much smaller number than 1. Obviously, it's not between 1 and 10. Here's my decimal point. If I move it to the left, I'm making it even smaller. So the only way for me to write this, be able to write it in a scientific notation, is to move it to the right. Remember that if I move it to the right, that means that I will have a negative exponent for my power of 10. My little n is going to be negative. To move this, the decimal point to where I get a number between 1 and 10, so 2.994, just like here, I would have to move the decimal point 26 times. Therefore, the way I express this number in scientific notation is 2.994 multiplied by 10 raised to the -26 kilograms. Note that since I moved it to the right, I have a negative exponent for my power of 10. And because I moved it 26 times to the right, that is going to give me the value of n. Note that this is the correct way to express a number because 2.994 is a number between 1 and 10. Here's a very, very large number. The decimal point is at the end of all of those zeros. If I move the decimal point to the right, I'm making this number even larger, and I want to make it between 1 and 10. Therefore, I have to move the decimal point to the left. If I move the decimal point to the left 23 places, remember that the power of 10 is going to be positive. So the fact that I have a positive number of 10, and I circle this one, but it's negative. But if I have a positive value for that exponent of the power of 10, that tells me that I have a very, very, very large number. If I have a negative exponent for the power of 10, that tells me that this number is very, very, very small. And therefore, to express this number, if I move the decimal point 23 places to the left, I will have 1.67 times 10 to the power of 23. It is positive 23 because I'm moving it to the left. Here are some values in scientific notation. Another sample problem. These are, some of them are small numbers, so smaller than 1, and some are large numbers. So remember, if you move the decimal point to the right, you have a negative exponent. If you move it to the left, you will have a positive exponent for that power of 10. I will once again give you some time to work on these problems, and we will then finish this section of Chapter 4.